So, good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss a worksheet on matter waves. So, let's begin with the worksheet. So, here is the worksheet on matter waves. The first question is de Broglie wavelength is. So, de Broglie wavelength is lambda is equals to h by p, where p is the momentum. P can also be written as m into v. So, lambda can also be written as h by m into v. Now we can write momentum in terms of kinetic energy as root 2 km. So lambda can also be written as h divided by root 2 km. Now if charge is q and it is accelerated by potential difference v starting from rest, so we can say that kinetic energy will be qv. So lambda can also be written as h by root 2 qv into m. Next are some graphs related to lambda. So first question is lambda versus m graph when speed is constant. So you can see that lambda is proportional to 1 by m. So the graph will be a rectangular hyperbola. Next is lambda versus v graph. So lambda is proportional to 1 by v, m is constant. Graph again will be rectangular hyperbola. Then is lambda versus 1 by m. So lambda you can say is proportional to 1 by m. So graph will be a straight line with slope angle theta, where tan theta is equals to lambda upon 1 by m. So after solving this, we get tan theta as h by v. Next is lambda versus 1 by nu graph, 1 by v graph. That will also be a straight line with tan theta is equals to 1 by m, h by m, sorry. Next is a charge particle having charge capital Q is accelerated by v volt. Charge starts from rest, mass is m. First question is find kinetic energy of charge particle. So kinetic energy is Q into v. Next is find speed of charged particle. So half mv square, I assume that the speed is v dash. So half mv dash square is q into v. So from here v dash comes out to be root 2 qv by m. Next is find de Broglie wavelength. So de Broglie wavelength is h by mv dash, and after solving we get h by root 2 q v into m. Next is lambda versus p graph. So lambda is proportional to 1 by p, so the graph will be a rectangular hyperbola. Another question is lambda versus 1 by p graph. So we can say that lambda is proportional to 1 by p. We take 1 by p as x, so lambda is proportional to x. So the graph will be a straight line. Next question is lambda versus q graph. So we can say that lambda proportional to 1 by q. So graph will be having a shape like rectangular hyperbola. Next is lambda versus 1 by root 2 root q graph. So lambda will be proportional to 1 by root q will be proportional to x. So the graph will be a straight line. Then is lambda versus frequency graph. So frequency proportional to 1 by lambda, 1 by root v, sorry, lambda versus v graph. So that will also be rectangular hyperbola. Then is lambda versus 1 by root v graph. So take 1 by root v as x. So lambda proportional to x. So the graph will again be a straight line. Next is lambda for electron. It is 12.27 by root v angstrom. Then is lambda versus v graph. It will be a rectangular hyperbola. Then is lambda versus 1 by root v graph. That will be a straight line. Then lambda versus 1 by v graph, that will be a parabola. So you have seen these are the basic level worksheets on matter waves, and these worksheets are designed so that you start preparing as per the requirements of the exam. Generally what happens is that students study in any haphazard and random way, and because of that they are not able to retain during the exam. You must have seen yourself. Just ask yourself that what chapter did you study today and how many questions you are able to retain. The variety of questions, formula used, concepts used, basic concepts, basic vocabularies of those problems. Then usually the thing is that as per the traditional way of study is concerned, you study in terms of paragraph. So that is very comfortable, but it is non-productive, because exams in competitive competitions are asked on very few selected and classified information. It refers to a particular case, and if you have studied in terms of paragraph, then during the exam time it's very hard to retain that classified information. It's just like there are about 6,000 A4 size pages, and exams comes from only 25 to 30 pages. So out of 200 pages that you have learned, only one page is significant. So there needs to be very high accuracy and precision to retain that much information which is required in the exam. So as per competitive exams are concerned, preparing in a paragraph type way is not going to help you out, because competitive exams are based on psychologically designed exam patterns, and they test your working efficiency, that how your mind brain system works. So normally a student is not able to retain the exact information which he studied uh, 1 or 2 year back. So the entire turning point behind cracking any competitive exam is the development of retention capacity, and it is not a one day process. It requires a considerable amount of time, patience, energy, and the most important thing, the emotions with which you work. Because if you are not working, you are not happy while working, that means the neural patterns will not be developed. So you will not be able to retain those things during the exams. So make sure before you study that you work on the basis of developing neural patterns corresponding to a particular topic of a particular chapter of a particular subject. Only then you will be able to generate the optimal output. Thank you and have a nice day.